We are talking about edge effects today. Let's go. So, we have talked about when ecosystems are disrupted. It happens all the time. It could be forest fire, agriculture, urbanization, roads, etc. But when we disturb these ecosystems and we kind of split them apart, we're going to alter this area. And that's going to produce the set of conditions known as edge effects. So you can kind of see them here. Here's an edge. Here's an edge. So we're creating these new edges that all once used to be forest, one ecosystem that is not anymore. So unfortunately, when we split up an ecosystem, the conditions on the edges, so right along this road here, are going to be so much different than the area much farther in. And we're talking maybe 5 meters in. Because this area here is getting much more sunlight, it has less humidity, much more wind, it has potentially other things interacting with it. And all of that is going to create these abiotic factors that are going to favor the community that's inside and make it much more difficult to live on the edge of these ecosystems. Now, we know we have our generalist species. If you remember, this is a great example of our generalist species. They're the ones who are able to colonize the edges of these disturbed areas. Our specialist species, they're going to be the ones in the middle. These generalist species here are not normally threatened at all by having to adapt to this new edge environment. They're actually going to outcompete many of the specialist species that are normally hanging out there. So these guys will thrive on the edge where our specialists not so much. Now, as I mentioned, as you move into the forest, this edge effect is going to decrease. So we're going to find more mature trees, a bigger canopy, more humidity, less sunlight reaching the ground, and we're going to find more of our specialist species that can handle these undisturbed environments in order to live. So a lot more biodiversity in the interior, where our edge is going to have a lot less, very little biodiversity in comparison. So we're going to talk about when we're looking at creating natural reserves, how does all of this play into part? So just keep that back in your mind. When we have large, undisturbed wilderness areas, this is good. Okay, these are all good things, so awesome. That means our large habitats can be stable. We can support so many species that can evolve and adapt. And that stability is going to allow for numerous trophic levels to build up. Our apex predators, as we know, they require large hunting ranges. So the larger the space, the more area that they're able to feed on, the stronger our ecosystem is. And in addition, our migratory species need to move as well in between seasons. So in general, here we go. This is most important right here. The larger the area, the larger the population, the more stable our gene pool, because we have a large biodiversity. Now, as a quick reminder here, we have some species, mainly our apex predators, not always, but most of the time, when they have a large body mass, so elephants, tigers, bears, pumas, they're going to have very long lifespans, very few offspring, very low population density, but they're going to require massive areas to hunt. So tigers, for example, require 20 kilometers squared to hunt and to fuel, while rabbits only require 0.01 kilometers squared. So if we're going to protect these large apex species, then we need massive areas for their habitat. Unfortunately, like in this example here, Many times the habitat is broken up to what we call these islands. And this has such a deleterious effect on the biodiversity and on the species in that interior. Our gene pool is restricted. Inbreeding often happens because they don't have the diversity in the genetics. So that leads to genetic defects. Our apex predators do not have enough space to find enough food. And then our species that rely on seasonal migration, they're not going to be able to reach their movement because it's going to be so restricted by these islands that have been created, unfortunately, most often by humans. So when we use agriculture, when we unfortunately take down trees with logging, or when we find oil reserves or coal reserves and start mining, this is going to cause the degradation of a habitat. And we're going to start creating those islands, unfortunately, because we're completely destroying ecosystems. Now, often before they do this, they have to meet with land planners or sustainability councils and decide, okay, if we're going to do this, we have to set aside areas of undisturbed land as natural preserves. It's so important that we keep island biogeography, we've talked about this, and this edge effect in mind. So we're going to kind of talk about how those decisions would be made. One example, this is up in Washington, is Olympic National Park. So this is an example of a reserve that has been created. Now this is a quite large reserve, but we're always having to vary the size of these based on negotiation between businesses and sustainability councils. Okay, so here's our first example. So if I'm trying to create a reserve, obviously bigger is better because I have a larger interior. Even though my edge is quite large, if you were to compare the percentage of our area here that is the edge compared to the interior, you would see that we have a much larger percentage of interior in this reserve than we do here. So the larger, the better. Now, even though we may have the same surface area, because of that impact of the edge effect, it's so important that we try to keep all of the area in one continuous space. Having this one large edge here allows for a large interior that can become extremely biodiverse. Unfortunately, in this area, even though we may have the exact same total surface area, our edge is a lot larger. We have 4 times the amount of edge. And so our interior is so much smaller, allowing for less species diversity. In addition, if I have a apex predator that needs to move, it's a lot more difficult to go to these 4. Same with migration, all of that. This is a much better situation. Now again, if we're comparing, if this is the one option, if this is another option, obviously having them closer together is much better for the ecosystem and the biodiversity. As I mentioned before, we do have migration, and the migration pathways are not that far from each other. Or if I'm an apex predator, I'm not crossing a large distance to get to these. This is a large distance for an apex predator. So this would allow for higher biodiversity than this would. Now, we have the same amount of surface area, but they're they're laid out in a different way. These are clumped together. These are spaced out a little bit more, just like the one above. If I'm a tiger, I can go to here or I can go to here. I can get to both of those other nature reserves quite easily. Where if I'm a tiger over here, this one's quite close, but wow, that one's really far. So it's much more difficult for me to get to this nature reserve in this setup than it would be in this setup. Many places have realized that, gosh, this is the only situation that we can provide you. And so sustainability councils have come back and said, look, that's fine, but you need to create bridges in between the two. This happens a lot in Colorado, where we have had highways come in and separate these nature preserves. So if we're building a highway in between these nature reserves, the Sustainability Council is saying, look, if you're going to build a highway, you've got to put in these bridges in between, over the highway or under the highway, so that we allow for that migration patterns to still happen. It's much easier for migration to happen this way or for hunting to continue than when they're completely separated without a land bridge. And then finally, this one's got the same surface area, but it's spread out. You can see that we have, again, much less interior. I'm going to block out kind of what we're going to call the edge effect. And you can see kind of our edge effect is much larger when it's this oblong, leaving very little on the inside. Compared, my drawing's not very good, there we go. Compared to when it's a circle, because we're so close to these other edges here and here. Where here I've got a great section that's very far removed from any edge, allowing for a lot more stability inside here. All right, we're going to talk about edge effects so much more. So, fantastic.